This video is going to go over transformations of functions and will cover horizontal and vertical translations, reflecting over axes, and stretching and shrinking. First, we need to look at the rules. So f of x is going to be our parent function. For our purposes in this video, it will just be kind of like a random picture. You'll see in a few minutes. First, when we have a plus or minus c on the end, that results in a vertical shift, where the plus c means we shift our function up, the minus c would mean we shift our function down. When we have a negative out front, it's a vertical flip over the x-axis, and to do that, we'll multiply our y values by a -1. If we have a number out front, that is a vertical stretch or shrink, and to find that, we'll multiply the y values by the a. If our a is bigger than 1, it's a stretch. If it's less than 1, it's a shrink. If we have a plus or minus c inside the function, inside those parentheses, it's a horizontal shift. But here, when it's horizontal, we do the opposite. So a plus c on the inside would move us to the left, and a minus c on the inside would move us to the right. If we have a negative on the inside, so inside the argument there, that's a horizontal flip over the y-axis. And here we would multiply x values by a -1. That's the only horizontal thing that doesn't result in an opposite. If we have a constant in front of the x inside the function, that's a horizontal stretch or shrink. And here, instead of multiplying like we did for vertical, we're going to do the opposite, which is divide the x values by a. And again, going with the opposite idea, if a is bigger than 1, it's going to be a shrink. If it's less than 1, it's going to be a stretch. So as we work with these, you'll see you should really get the hang of it pretty quickly. What's nice is these rules are true for any function. Absolute value, quadratic, cubic, square root, on and on and on. So as long as you can remember these rules, which once we've done a few, I think you'll see that you can remember them, you'll know how to handle any function. And a quick summary here is that if it's outside, it's vertical, that affects y. If it's inside, it's horizontal, that affects x, and it's usually the opposite. So let's look at an example. So here is just our parent function f of x, and they want us to draw f of -x. We'll start by making note of the ordered pairs for the endpoints. We'll do endpoints and any vertices. So when we have a negative on the inside, that results in a horizontal flip. And for a horizontal flip, we multiply the x coordinates by -1. So it's the x coordinates because it's horizontal. So there's the first coordinate multiplied with the x by -1 and the second one. And then we just plot those points and draw our graph. Next, here we have g of x. So first we'll put our ordered pairs on, and again we're just looking at the endpoints and the vertex there. Now we have a negative on the outside, which means it's a vertical flip, right? Outside is vertical, and the flip is going to result in us multiplying the y coordinates by -1. We're doing the y coordinates because it's vertical. So our -4, -5 becomes -4, 5, right? Just multiplying the y by -1. And we do the same for our other two ordered pairs. And then we just plot those points. Next, here, instead of a flip, we have something else going on. But first, let's find our ordered pairs. Now, we have a 2 out front, and if there's a number outside, it's a vertical, and it's a stretch because that number is greater than 1. And vertical, remember, is going to result in us dealing with the y coordinates, and here we're going to multiply the y coordinates by 2. So -2, 4 becomes -2, 8. We're not doing anything to the x coordinates. and then we just continue. Our origin doesn't change. There's our third point, and we just plot our points. Here we just have a line. We're going to look at our ordered pairs, and then we're going to see what they want us to do. We have a number on the inside, so this is a horizontal shrink. Remember, shrink is going to be the opposite. So we're going to divide the x coordinates by 2. So our 0, 0 doesn't change, but our 4, 4 becomes 2, 4. Again, we're just dividing the x coordinate by 2. We're not doing anything to the y coordinate. And then we plot our points. Another one. So here we're going to find our ordered pairs. And then we have a 1/2 out front. If the number is outside, it's vertical, and this is a shrink because that's less than 1. It's vertical, so we're going to be dealing with y coordinates, and we're multiplying them by 1/2. So if I have -2, -2, if I multiply the y coordinate by 1/2, I get a -2. My 0, 0 doesn't change. And then there's my third ordered pair, and then I just plot those points. Last one like this. Put on my ordered pairs. I have a 1/2 on the inside, so remember inside is horizontal, and this is going to be a horizontal stretch because that's less than 1. Remember, it's opposite because it's x, or horizontal. So we're going to divide the coordinates by 1/2, which is the same thing as multiplying by 2. So my -2, -4 becomes -4, -4. Remember, I'm not doing anything to the y coordinate, only the x. 0, 0 stays the same. There's my third ordered pair, and then I'm going to plot. Okay. Oh, I may not have given you enough time with that. Okay, now we're going to do 3 other examples, or maybe 2. Now I don't remember how many are on this thing. So we're going to start the exact same way with our ordered pairs. But notice in our new function here, we have 2 things happening. First, we have a negative outside, which is a vertical flip, which tells me I'm going to multiply my y coordinates by -1. I also have a +2. And if I have a +2 on the inside, that's a horizontal shift to the left, which means I will subtract 2 from the x coordinates. Remember, I'm doing the opposite. So to sum it up or put it all together, I'm going to take my original ordered pair, subtract 2 from the x coordinate, and multiply the y coordinate by a -1. And here you can see the work for doing that for each of the ordered pairs. And then once I have the new ordered pair, I just plot them on my graph. Here, again, we're going to put our ordered pairs on. Next, we have 2 things happening. We have a number on the inside, which is going to be a horizontal shrink. That means that we are going to divide the x coordinates by 2. We also have a -3 on the outside, which is a vertical shift down. That means that we will subtract 3 from the y coordinates. So looking holistically, we'll start with our original ordered pair, divide the x coordinate by 2, subtract 3 from the y coordinate. There's the work for each of those ordered pairs. And then we plot our answer. Oh good, we have one more. There are 3 examples. So here, find our ordered pairs. We have a number on the outside, which is going to be a vertical stretch. So I'm going to multiply the y coordinates by 2. And then I have a -4 on the inside, which is a horizontal shift right 4, because remember, when it's inside, it's opposite. So that means I'm going to add 4 to the x coordinates. So I'm going to take my original ordered pair, add 4 to the x coordinate, multiply the y coordinate by 2. Then here's the work for each of those 3 ordered pairs. and then I plot my answer. So in summary, it's important that we remember outside is y and vertical, inside is x and horizontal, and the opposite, except for a flip, because there's really no opposite of multiplying by -1, right? So if I have a plus or minus a number on the outside, that's a vertical shift in the same direction. A negative out front is a vertical flip, and I would multiply the y coordinates by a -1. And if I have a number out front of my function, that's a vertical stretch or shrink. It's a stretch if a is bigger than 1, a shrink if a is less than 1, and I'm multiplying the y values by that a. If I have plus or minus a number inside, that's a horizontal shift in the opposite direction, so that will affect the x coordinates. If I have a negative on the inside with the x, that's a horizontal flip, so I multiply the x coordinates by a -1. And if I have an value with the x, a coefficient there, that's a horizontal stretch or shrink, but remember it's opposite, so it'll be a stretch if the value is less than 1, a shrink if the value is greater than 1, and I divide the x coordinates by that value. I hope you found this helpful. Good luck.